Um, I would like, well, Michael already introduced himself, and he has done a lot of work with data science and different things in the state of Ohio. And we are very pleased to have him join us today. He will be talking about a strategic investment in Ohio's talent pipeline. And I'm going to stop sharing.
All right. Well, thank you for having me. As I said, my name is Michael.OShaughnessy. I am from the Montgomery County Educational Service Center. The bit.ly to this presentation is up there. It is case sensitive, so it's all capitals, OMSC, and a capital 2. Got to talk to those math people. Got to make sure they get their capital 2 and a capital E, right? And the QR code will get you there too. Sharing the bit.ly and the QR codes, view only for this presentation, because there are some links in there that you may want to take a look at. Also, there are several added notes to the slide that I won't be talking about everything that's on there. So you may want to go back and take a look at it at some point in time. Okay? But as we move on, again, this is me. I've been in education now. This is what? I was going to say 4-8-ish year, but I think some of you have me beat. So normally I'm the one that's been the longest, but that's okay. So 28 years now. My first 17 were in the classroom. I taught physics and chemistry at Charlotte Joint Catholic High School in downtown Dayton, and then at the Greene County Career Center in Xenia. So my passions are science and math. I used to say that physics was just applied math anyway. My students would walk into my classroom and go like, I just left math. I'm like, well, the whole reason you're taking that math class is to be in my physics classroom. So I enjoyed showing my big presentation was when we would get in there and go, okay, it's math class time. And I would have a set of data up there and we would graph the points and we'd get a straight line out of it and we get y equals mx plus b. I go like, okay, you ready? Now it's physics class. And I would just change x to t and y to d. So there you go. You've been doing physics, you just didn't know it. So it was fun, and I did enjoy having the opportunity to help with the students understand math a little bit better. This is not to say our math teachers are not good. We have outstanding math teachers, but I will also say that it's been my experience in education that many of the math teachers are very abstract oriented, shall we say? Like solving a quadratic formula on a Friday night is fun to them. And they don't understand why it's not fun for their kids. So we end up having an issue with some of the math teachers trying to bring the real world scenario into the classroom. And that's one of the things that our algebra 2 equivalent pathway that is much better or provides a better avenue for the student. Okay? So our agenda for this, we're going to talk about why is the algebra 2 or why are the algebra 2 equivalent pathways? Where did they come from? Why are they A2E? We're going to specifically talk about the data science foundation course. There are 4 courses we're going to specifically talk about data science. We're going to go over the mission and the vision and of course overview. We do want to touch on our graduation requirements. This is something that for the graduating class of 2018, I think it was, every year that they were in school, their graduation requirements changed. So it's crazy for them. But I think they have a pretty good approach to graduation requirements now. So that's good. And of course, we'll end with any questions. Okay? So let's start with the why. We've got this nice big bridge that connects one place to another, right? That's what bridges do. But also is a path. Yeah, and it's like, this is a path you can follow. You can get from point A to point B, and it kind of guides you from one side to the other. So just kind of think about this and keep a bridge in mind as we go through. What has been happening in the state of education and math is Algebra 2 has been an obstacle for many students. They get to Algebra 2 and they just have problems with it. They don't understand it. They just, for whatever reason, Algebra 2 and the students, they just don't click. Now, this is not for all students, but a good majority of them have issues. So what happens is Algebra 2 becomes this hurdle, this obstacle that many students can't overcome. If we have this situation, we have another problem, because once they go out, if they don't graduate, okay, if these students don't graduate, 94.2% of the non-graduates never got credit in Algebra 2 or Math 3. So not only is Algebra 2 being kind of like an obstacle for students that we can't get them over that hurdle, if they drop out, they aren't prepared for anything because they don't have any, advanced math behind them. So this is an issue, especially today, because this is just kind of like a snapshot of things that people need to do today. You've got huge data analytics. You've got huge computer skills. You've got huge data analysis. I mean, just about any career, any profession that you're thinking about now, the workers, the employees have to be familiar with it. Amazon drivers. I mean, this is kind of pretty interesting. They need to be able to look at their device, know where to go to the next address, know how to take a picture of what they dropped off, and know what happens if they miss a drop off. That's technology. If they are not technologically literate, they can't do their job. Okay? So, if we take a look at our jobs landscape, right now, back in this 2018 to 2028, see if I can whip this guy a little bit more.
Maybe.
Hang on. It's going to be there. That's a little better. We see statisticians, so 2018 to 2028, just jobs prediction, if you will. Statistician, 31%. That's how much this position is going to grow. If we look at, technology, gotta love it when it works, right? So information security analyst, 32%. There we go. So these two growing 31 and 32%. And look at how much they're paying median for the year. These are jobs that are growing. We need people to fill these positions. Operations research analyst, 26%. So the growing field is very technologically oriented, data oriented, math oriented. Software developers, might have missed my column there, 103,000 a year. Mathematicians, just flat out mathematicians are needed as well. A lot of careers. It's not like it was back when I graduated. The updated one, 22 to 32. Look what made it to the top. Data science. What is happening in the world today is, as you all know, the AI has come out, and there is a plethora of data that's generated every minute. I used to know the number that Google presented, but it is a staggering amount of data that's generated every minute. There's a staggering amount of data of videos, of minutes of videos that are uploaded to YouTube every minute. I mean, the number is astounding. So we've gone from having people just kind of like crunch numbers to, you've got terabytes of data. What does it tell you? The OTES 2.0 rubric for teacher evaluation has shifted to data. They said, how are you using data to inform your classroom instruction? So now you've got teachers who all they wanted to do was teach kids how to read and write and play on the playground, now have to collect data and analyze it. So, and if you see the rest of it, besides operation research analyst. So the career field is drastically changing. Top 10 emerging. Look at number 1. number one and number two actually go together because a true data analyst will learn how to do machine learning. So they'll generate a model and they'll have to train that model. And the better they can train their model, the better their paycheck's going to be, basically. The 10 that are going away: data entry clerks, accounting, bookkeeping, payroll. Those are all things that if you know what you're doing, you just ask AI to do it for you. Now, I liken AI to this, okay? I've seen people put questions into AI, some prompts, and they get something back, and they think it's the best thing in the world. I'm like, no, that's not going to work. I can look at it. I can tell you right now. You know, I've seen like programming, they'll come back with some code, and I'm going like, no, that doesn't work. But what's nice is if you know how to code and you ask that question, you can see what they gave you and go like, oh, okay, I see how you tried to attack that problem. Let me do it this way. I've used AI a lot in that sense, especially for like HTML coding. I know how to write it. I know how to do tables. I know how to do lists. I know how to do all that coding. But I'm like, I do not want to do this by myself, right? So I copied the list of stuff that I needed in the table. I threw it into ChatGPT and I said, give me an HTML code for all these in rows, 3 columns wide, 8 rows long. There it was, copy and paste, put it in. I could have done it. It would have taken me an hour. I was done in 2 minutes. So that is where we want to go with AI. Brian and I were talking a little bit earlier about it. We need to make sure that educators are using AI to improve their instruction in the classroom, not shy away from it. How can they make it better? Okay. Notice the emphasis on data and computers. Students need to know how to program. Students need to know how to code. They might not need to know how to write the program, but they better know the process. And we all know in this room that a computer program is an algorithm. There are algorithms to solve math problems. So the better they are at coding, the better their math skills are going to be. The better their math skills, the better their coding is going to be. Right? That's the goal. So what did the Ohio Department of Education Workforce do? They've got this proposed solution to all these issues. What they looked at here was Algebra 2 tries to solve a couple things. The first one is it's a graduation requirement, because it is. To graduate from school in Ohio now, you must successfully complete or obtain credit for an Algebra 2 course or the equivalent. Yes, that's why they changed it. It was also viewed as preparation for pre-calc. And a lot of us are like, well, okay, if that's what you think. Doesn't need it well, right? I mean, if we've got kids hitting that Algebra 2 requirement and not getting it and then dropping out, and then we've got kids that, think that they're going to get into pre-calculus and they can't get past Algebra 2, we've got issues. So they wanted the Algebra 2 equivalent courses, A2E courses and pathways. So it changed from an Algebra 2 credit to an Algebra 2 equivalent credit. What this will do is it'll improve the students' achievement in mathematics. The students will now have some choices here. They don't necessarily have to take that Algebra 2 class. If you got a student that's, not ready for Algebra 2, if you will, that are just struggling in math a little bit, the Algebra 2 equivalent courses are a better fit for them. They're still rigorous, which we'll talk about, so that's the same rigor as an Algebra 2 class. So it's not like, oh, you can't handle that. A common speaking phrase in these courses are, I didn't know this is math. And that is like, oh, So I prepare high school students for creating coherence between what they're preparing for in high school to what their job's going to be out in the real world. It's still happening today. Our 7th graders, probably half of them are going to work in a job that doesn't even exist. So how can we prepare them for that? Back in the day, back when I was guys from Fairmont, I have a rival. I graduated from Fairmont West. When I graduated from Fairmont East, it was pretty straightforward. You went to college or you went and worked at the, auto body shop or something like that. That was pretty much your choice. Now, if a kid takes the Data Science Foundation course their junior year, they could go to a certification boot camp between their junior and senior year, get a certificate, and they can work as a freelance data analyst their senior year, making more money than their teacher with this much college. Okay, so we need to make sure that college is not for everybody. We still need to make sure that our graduates are college ready. So if they choose to go to college, they're ready. If they choose to go on another career path, they're ready for that as well. So that's our goal. It's an and, not an or. And they have to be ready. But no more is it like, oh, you have to go to college. Okay? So if this happens, it's win-win for everybody. Students are going to graduate. We're going to get a high graduation rate. The employers around the city, town, state, so forth and so on are going to get good employees that are trainable. And that's what we want. So what are the 4 courses? The descriptions of each one of the courses are at that little bit. First one we're going to talk about is Data Science Foundation. That's the one that you'll hear more about in a moment. The second one is quantitative reasoning, mathematical modeling. This was the first one that came out, and it is a very wonderful approach to math. When I went through the training for MMR, what I was looking at was like, oh, a lot of their activities were like, oh, I did these in physical science, or I did these in physics class. They were dropping G.I. Joes and Barbies on rubber bands off the stairwell. I'm like, yeah, I know that. So it was very impressive for me, a physics/science teacher, to watch math teachers' brains work as they work through this problem. I'm going like, well, it's a science thing. What's the problem? They're like, well, they're doing calculations in their head. I'm like, just collect the data, put it down, it'll be okay. So the flip side of this is the activities are more along the lines of what the students' lives are. One of the activities is they have to decide whether they should save some money to buy a car or go ahead and get a loan and pay for the car. One of the activities is also to go get gas. There's a gas station that sells it cheaper that's miles away, and there's a gas station down the road, but it's a drive back and forth. So these are awesome questions that they have to do in their quantitative reasoning class. Discrete math computer science course. This is an awesome course too, highly involved with it. They are given it's very interesting because they're given gaming situations. And they learn to write code to solve the best solution for the game. There's a tie 21 that was one of the big things on Survivor, where there's 21 flags out there, and the teams take turns. They take 3, 2, or 1 flag, and so they have to play the game to figure out what the logic is behind the game. Then they have to figure out what is the best way to win the game. Then they get to figure out how to program it, and the programming is good in the sense that they don't. It's more of a I'm going to say copy and paste, but it's more of a read, paste, and observe. So they don't have to write from scratch. Dr. Orban from OSU got it set up where they change the code in between two lines of code, and they adjust the code so they can see. So the other point of that is we say, hey, so you put that in there, change that 5 to a 25, and look what happens. So this is good because they don't have to learn coding from scratch. They get to see it actually in use and be very successful, because if they do just copy the code, it's going to work. But then the next step that we try to train the teachers is we say, hey, look, now that they got it, have them experiment, have them change something so they can see it and look and do something else. So it's very, very cool. They do things like that, 4 down, type 21, crack the code. They have to come up with it. They've got an iPhone that they need to break the security code for it. So they learn about cybersecurity. They learn a way to do a brute force PIN or password cracking. It's really cool. And statistics and probability. For statistics and probability, the state decided that, look, in just about every high school in the state already has a statistics course in their catalog. So that was not one that they decided to develop. So the first three, data science, quantitative reasoning, and discrete math, were written from scratch by Ohio educators, except for data science. We'll talk about that in a minute. The statistics and probability already out in the high schools, so they're like, why reinvent it? So these are the four Algebra 2 equivalents, the A2E. If a student takes one of these courses, passes it, they meet their Algebra 2 equivalent requirement for graduation. Again, like we talked about, it is rigorous. And what I think is great about one of the, what shall we say, the byproducts of, okay, fine, of these courses is, hang on. That, no. But we'll leave it like this for now, because we're just going to talk about it. I forgot to change it. It opens the Adobe, and I don't want to open it.
Are you want to enlarge it? Lower right.
There it is. Thank you very much. Thank you. I was looking for a magnifying glass, but I didn't look down here in the least correct area to find it. There we go. So, what we're talking about on this document, the issue that the state had to overcome with the creation of the Algebra 2 equivalent courses is they would be challenged on rigor. So a lot of high school math teachers were like, no, Algebra 2 is a very rigorous curriculum. And if you trade it out for anything, it can't be anything that's less rigorous. So then the state looked at the Algebra 2 teachers and said, excellent, define rigor. And they all go like, yes. And we're like, okay, guess what? So the state took the time to actually define what rigor is. So you can see that rigor courses defined by complexity, which is a measure of the thinking, action, and knowledge. It is not by difficulty. Okay? Rigorous courses aren't just more difficult. There's more complex, higher order thinking skills are necessary. You look at measured in depth of understanding, measured by the amount of work. In the Algebra 2 equivalent courses, the students, they get homework, but it's not a lot. They don't sit there and do worksheet after worksheet. They do a small amount of problems, but they go deep. Compared to a traditional like Algebra 1 class or Algebra 2, then like, here's your worksheet of 50 problems, do them, and I'm going to make sure that you did every single one of them, get back, and you didn't do your homework, so now you fail my class. No, we don't want that anymore. We want them to be rigorous. Determined by student process, measured by assigning difficult problems. In these courses, the students are going to be at different levels. We've got students that can come in and they may already know how to code JavaScript for the discrete math class. So they're going to fly right through it. You've got other students come in and they're going like, a what? Java who? And they're going to need to be looking at from scratch. But the idea of the whole class is it's that low entry, high ceiling type thing. Every problem, every student can attack because they can get in at this level. But how deep they can go or how high they can get from that problem is huge. That's what a rigorous class is allowed to do. Students make decisions and problem solving defined by the resources used. Traditional math class, teachers at the front, this is how you solve the problem, you do it. Oh, you didn't solve it like me, you're wrong. We can't have that. You all know that there are more than one correct answer to many situations. And it's more important on how did they get to that answer. I have discussions with math teachers about calculators, and I also have discussions about memorizing their multiplication table. Part of me, old me goes, they just got to know. They got to know that 2 times 3 is 6, 2 times 7 is 14. They just got to know it. But then kind of newer me goes like, really? Because all you got to do is say, hey, Google, what's, and they're going to get the number. And when I'm on this side, I go, what's more important is that they look at the answer and it makes sense to them. I don't know how many times students came up to me in physics and we took 10 divided by 2 and they said the answer is 200. I'm like, how'd you get that? Well, that's what my calculator gave me. I'm like, well, calculator just failed, what can I tell you? So I would much rather have the student look at 10 divided by 2 and an answer of 200 go like, can't possibly be 200. I'm taking a number and dividing it. It's got to, by a whole number, it's got to get smaller. I didn't divide by a fraction, so there's no way it's going to get bigger. That concept, if they have that concept, then fine, because calculating a number is secondary. All right? You can peruse the document if you want. The link is in the presentation. But again, like I said, the byproduct of this is we now have a definition of what a rigorous class is, or what rigor actually means. And trust me, during our training for all three of these courses, we definitely make sure that the teachers are trained on that they know that this is not a easy class, and that this is a rigorous class. We're also working harder this year on connecting with our school counselors to make sure they understand the same thing. That, it's not that, oh, the kids will never make it through algebra 2, put them in this class because it's easier. No, it's different. It's just difficult, it's just different. So now look what we have for the state. The state has many pathways for students now. Algebra 1 and geometry are your basics in high school, right? So they can take your Algebra 1 and geometry class. Then right after that, they hit in the middle of that wheel. They can take their Algebra 2 course if they want. And then from Algebra 2, they go pre-calc calculus. That's fine. We have many students that, are on that track. They're doing that. They know they're going to be doctors, lawyers, engineers, what have you. They go right through there and they're going to be just fine. Their mental capabilities and their skills are set that they can do that. But we have several students that just aren't ready for that level yet. So now we give them options. Statistics, data science, discrete math, quantitative reasoning. That's the other kids. They have other pathways. And these pathways also they can still go to our college credit courses their senior year. This doesn't stop them from pursuing a college level course. The other thing is it doesn't stop them from getting to calculus. That's another topic that we love talking about. Not every student has to get calculus in high school. Not every engineer took calculus in high school. All right? So they don't have to have calculus in high school. If they need calculus, they can go back to school, and I'm sure there's somebody teaching calculus at college. I mean, I took it at Sinclair, so I'm sure there's at least a calculus teacher there teaching, right? So, but by, I'm going to say, delaying them for a year, they're one more year, they're 1 year older, 1 year a little bit more different type of math in their frame of reference. They've been introduced to a whole bunch of different math topics from different perspectives. Their brain is ready for calculus now. So then they'll do better in college when they take calculus. And that's if they go there. They don't have to. Many of these pathways go to careers that don't require college. Sorry, college professors. So, thinking about a bridge. We're trying to get from one point to the other. We're trying to get students from one side to the other. We're trying to get them to graduate and prepare them for what's to happen after. So, in a nutshell, why did they do all this? It's in the best interest of the students. That's what all educational decisions need to be based on. It's in the best interest of the student, and we need to do it. If it's not, then why are we doing it? Okay? So by creating these algebra 2 equivalent pathways, it has caused this to be better for the students. Graduations will go up. Employers are going to be happy because they'll have better prepared employees. Just win-win for everyone. Okay? So now, let's go ahead and talk specifically about data science. My favorite. Data science over there, you can see the big list. If you just look at the Venn diagram there, that is one of the best ways to kind of describe what data science is. It's a combination of quantitative reasoning, your statistic probability, and your computer science. You need a little bit of all that to be able to do data science. We also want to make sure that data science focuses on using the data to make predictions and decisions. So a data analyst is going to look at the data, have a question, and answer. So that's the idea of a data scientist or a data analyst. So if you get more specific about some other data science, data analysts, you have others that are just doing things for knowledge. You know, they've got a whole bunch of data, they have no idea, they just start crunching numbers and they go, oh, look what happened. You know, that's pretty cool. Case in point, a little bit like that is, I just lost his name, it'll come to me in a minute past. There is a educational researcher, and what he does is Hattie. There we go, Dr. Hattie. Dr. Hattie's work is he does meta-analysis. He gets everybody else's work and he throws it in his analysis program and looks what turns out. So he doesn't really start with that much of a question. He just looks at what is happening to the data when it's all done. And then he comes up with conclusions. Teacher collective efficacy is like the best predictor for student success. Homework is one of the worst predictors for student success. He didn't start with that question. It's what came out of all his analysis. Okay? So like I said, coming here, the Data Science Foundation course is actually a tale of two portions. When it just started, the state partnered with UCLA. UCLA already had a whole year curriculum of data science. They used the statistical package R to teach the students how to analyze data. And they were trained by UCLA trainers. The focus was kind of split between R and data science. And if you've ever used R, it's a very steep learning curve. Very steep. I enjoy it. And it's like, still, it made me go like, what's going on? When we were training some teachers, and then with the coding, we got into the conditional statements. So if this, then that. So there was if, and it showed a variable equal sign and an exclamation point. They're like, oh, well, that means factorial. I'm like, yes, it does. But in this case, it means not. So what does that mean? Yeah, welcome to coding, right? So when we started, and this side too, it costs money. We had to pay the UCLA trainers per teacher. That's about $5,000 per teacher. They have their proprietary package to use in RStudio online. So you have to pay for access to RStudio Cloud. So it's not free. We decided that, or the state decided that that's not good, because discrete math, computer science doesn't cost. Quantitative reasoning has some cost to it. So how can we have a data science course where schools are going to have to come up with, $20,000 to, implement? So we were tasked to come up with an Ohio version of the data science course. So what we did was we looked at everybody that was involved with the Ohio version has been trained by UCLA and has seen it. We even had 2 people actually were classroom teachers with the UCLA version. So what we looked at it though is we said that we think that the emphasis of the UCLA course is a little bit off. We sat back and we're like, what do we want to focus on? And the focus was, we want to focus on the data analysis, the data science, that stuff. We don't really worry or mind or care about how they do it. We want them to know what they're doing. So the tool is secondary. So what we did was say like, okay, there are a lot of free tools out there. Google Sheets, Kodak, RStudio is free. Colab from Google is there. Looker Studio, which is just like Microsoft BI stuff. So we have free tools. Training is going to be provided by Ohio educators. So the ESCs are going to learn. We're going to get into a train-to-trainer type model. So this will be sustained for years to come. So when we have new teachers, we'll have the training resources in place. Boom, they're going to get it to little to no cost. We're focusing on the data science part. We want them to understand what mean, median, mode is. What are you doing when you do a pivot table? What is a frequency table? Why would you use a frequency table? Why, when you do a frequency table, it gives you numbers that you don't understand. Did you do a frequency table right? Did you try to do it with, with numbers or categorical data? So we want them to think about that. Plus, we like the easy entry point. So we start with Google Sheets. Just about every teacher has used the spreadsheet. just about every student has seen a spreadsheet by the time we get to a junior in high school. Because if they've gone through a science class, they've seen a spreadsheet. Okay, may not be a Google sheet, it may not be an Excel sheet, but they know what a spreadsheet is. So we kind of lowered that so that when they come into the class, the teachers and the students can focus on what's the math, what's the data analysis, what's the statistics, what's the probability behind all this. When we move from Google Sheets and we introduce a new tool, what we do is they actually redo an activity that they did in Google Sheets in the new tool. So now they know what they're supposed to get. So now they're not worried about that. They can focus on using the tool. So like when we move from going from Google Sheets to RStudio, they redo the same. It's the Titanic sinks, and one of the things that they figure out is was it better to be in a higher price cabin or a lower price cabin? And they looked at who survived. They also look at male-female survivorship, and they do all that using Google Sheets. So they know what their answers are. Now we get them into RStudio and say, okay, you're going to do the same thing, but we're going to do it with RStudio. And it'll be the same thing when we go into CoLab and they start using Python. They'll be like, remember that last lab activity you did? They do it again, but you're going to use these tools. And then the very end product that they do is they will learn how to use Looker Studio, which if you're familiar with that, it's pretty much a data dashboard. You can make pretty graphs, pretty charts, make things interactive. It's all fed by data in the back end from either a spreadsheet or SQL database somewhere. So through the course of the year, the students will be introduced to Google Sheets. They'll see RStudio, they'll see Google Colab and Python, and they'll see Looker Studio from Google. So in our view of it, we get the students introduced to 4 tools instead of just one. And I've had people argue with me on this one, but I argue back. I go like, okay, well, how many data scientists or analysts have you talked to? And then most of them are teachers that push back on it. And they go, well, you know, 1 or 2. I'm like, okay, well, we talked to a lot. And you want to know, when I ask them and said, do you know how to use a spreadsheet? They're like, well, yeah, that's the first thing I ever used. That's the first thing we tried. We throw it in a spreadsheet. If it works, then we go like, okay, let's pull out the big gun. So they're experts at using Google Sheets. So, well, they're not getting the coding. I'm like, yes, they are. Because what's the difference between a Google Sheet? You say equal sum C2 colon C22, or if you're in RStudio in the console and you go, give me the sum of this data set. You're doing the same thing. So even what I would consider coding, they don't do in the UCLA program. They make one function the whole year, one. Everything else is just command line. So they write one thing out of the command line, get the answer. Write another command, get the answer. So at least what we're going to show them is how they can actually create more programs, especially out of Python and Looker Studio. So that's what we have there. The mission is the data science course. Read it right there. Won't read the whole thing to you. But the idea about the mission is every day. So this is what the teachers are supposed to be doing in their classroom every day. And if you see, it's critical thinking, creativity, and problem solving. If our students are doing that in the classroom every day, that's a success. We need them to be thinking from the time they walk into that classroom to the time they walk out. They have to be that way. The vision is what we're looking at lifelong, right? 5 years, 6 years, 7 years out. And the idea here is we want to make sure that they start to understand to question some things, especially now. How many times have you heard, well, this poll says, 48% this and 52% that? I even, now I'll even go, my words after those percentages come out and go like, well, what was your sample size? Where was it? I mean, if you're saying your sample size was 400 and that number is supposed to represent the United States, I got to run up the red flag on that one. I'm like, nip. Did you interview 10 people and you say 9 out of 10 people like chocolate chip ice cream? Well, then you say that the world likes chocolate. No, you can't do that. So we have them start doing those things. They will learn about bias. They'll learn about looking to make sure that the statistics that they do crunch actually support what they're doing. They're not putting their own spin on things. We do talk about biases that you can't, everybody has their inherent biases, and there's no way you can get away from it. The way you get away from it is to be working on it. That's why they collaborate in this class, because my biases won't be exactly like somebody else's. They'll be able to bounce them off. They're like, oh, no way, you did something wrong. So that's what we want them to do, to be able to question the data that they're seeing. So they're going to be informed citizens. So they're not snowed by, a graph that, all of a sudden the scale changes. It's like, well, why'd you do that? Well, because they wanted to show it go up really high. When you pull it back and put it in a proper scale, it's like a line. Like, wait a second, it didn't go like this. So, what will they study? So, reason to think critically about all this data here. Sampling is a big one because we talked about that. As they get an idea of, we're talking about a sample. You only have 500 sets of data. This is, you're going to make assumptions or conclusions saying that this is what the state of the nation says. Based on this 500 sample, there are ways for data analysts to show how good that is. So the qualities and, standard error, standard deviation, all that good stuff comes into play. So they can say, yes, my sample should be within reason what the whole state or the whole nation would have. Bias and uncertainty probability. Modeling with data is a big one. 2, we want them to see that they can create the data, or they have the data. They can split the data into test data and their learning data and their test data. Have them create the model and see what they need to do to improve the model. So it's not super in depth, but they get an idea of what it would be for instance, Target. They want to know why people buy a certain thing or certain product. Well, they collect all the data and they can crunch the number and they come up with their model as to why people get it. And then now they can say like, well, what we have found in our model is that girls between 30 and 35 Friday night at 5 o'clock buy this. So if you can force that to happen, you will sell more. Okay? Crazy. But we talk about the models that way, right? Some more reasons why we want to do the data science. Student choice. Once they hit their sophomore year, they have pretty much been told exactly what they're going to do. You need to take this math class, you need to take this science class, you need to take this social studies class. Finally, their junior year, they get to say like, oh, wait a second, I could do a data science class, or I could do a discrete math class, or I could do a stats class, or I could do the quantitative reasoning class. So now they have a choice, and it's not going to stop them from graduating. Okay? The other interesting thing about the data science class, you would be surprised, but English majors. So those students that even know they're going to go out and be journalists or writers love the data science class. They love the ability to showing and presenting what they just found out. And at the same time, they're like, I'm going to be writing on this stuff, so I need to be able to understand what they're throwing at. So I was just really surprised that our English majors like it. Touch on teacher evaluation system, the pedagogy that we train the teachers on to implement the course in the classroom matches up with their evaluation system, so they are doing things that they're going to be evaluated on anyway. Career options, we just talked about that. We showed how the data science computers are showing, so now they've got a better pathway to those. And the assessment options for those that are still teaching, this is wonderful in this one. All of the algebra 2 equivalent pathways, none of the curriculum has any assessments or tests in them. The idea is that the state did not want to get in the assessment or test business with these courses. So that is these courses. Yeah, for these courses. Yes. Just these courses. So it is a local control. So this is out on the teachers. Now, the discrete math has a discussion board. I think quantitative reasoning does too. Data science does. And what's the first thing the teachers start doing? Hey, do you have any, can you share your quiz that you used on this section? So it goes back and forth that way. But our stress when it comes to assessment is this is the perfect opportunity to think outside the box. Everything the kids do in these algebra 2 equivalent classes is a performance. So they should performance or competence. So you should be grading their competency on it. can they do this? So you could sit down with the kids and data science, say like, okay, can you import data into a Google Sheet? Yes, you can. Okay. Can you find the mean, median, and mode? Yes, you can. They're good to go. So it should be more like that. So we're finding a lot of teachers are adjusting the way they're assessing because they're like, we're assessing all the time. I'm like, well, yeah, you did that before. You're just more aware about it now. So they're more of, did you do it? Did you not? Can you do it? Can you not do it? And if they can't do it, what can I do to help you get through it? So that type of assessment is a lot better in the classroom. Interesting enough, I know of a teacher that teaches in Columbus. She has actually changed her teaching practice in her other classes to make it more along the lines of what she's doing for data science. That's pretty cool. All right. Teacher resources, we have all the resources available for them. They do not have to reinvent the wheel, and they're there for them to use. So it's like, here you go. You do not have to reinvent the wheel. But the Ohio version is all done in Google Documents. So if they want to make a copy of it and change it up themselves, go right ahead. We had some teachers, we do what we call a Unit 0, which focuses on the mathematical practices. The teacher didn't like one of the activities that we chose, and she liked another one. So, okay, I'm just going to do that one. Woohoo, okay. Some of them are a little worried. Do I have to do exact one? No. It's your classroom. It's your students. You know what you can and can't do in class. This is just here. You didn't have to come up with it yourself. Another one is we do have curriculum for the whole year. A lot of teachers look at this and go like, I'll never get through it in the whole year. But that's okay, right? Get to where you go with the students. I'm like, are you talking about data science and math in the classroom? Are you asking them to think critically and solve problems? Yes. Are you hitting the mathematical practices? Yes. You're a success. Keep going, right? Whether they get all the way done or not. Okay? The 6 big points that are in data science there, we do make sure that they talk about how they communicate the results, because that's a big one. A lot of times in the traditional science class, they do their lab and they turn the lab report in, and that's it. Not in the data science class. They have to stand up and present. So they have to have their board, their PowerPoint, their Google slideshow, what have you, and they have to communicate their results to the class or somebody else. They work on making sure that they get their visualization. So they got to have graphs, charts, so they know what those are and know when to use which graph and chart. Data collection methods, traditional, modern. They will work on collecting data, real-time data for them. UCLA had an app to do that. Our teachers, our educators were able to convert it over to using a Google form, and we achieved the same thing. The one step that we have to do, though, is we got to get rid of the kids' names in the data. Their names are there. As soon as you splice off the names, you can use the data. But they collect data on, like, the first one is food habits, and they have to track every snack they eat. They have to write down what it was. They have to input what it is, how many calories it is, how much fat, how much sugar, how much sodium, I think, is in them. And then that's their data. And then by the time that food habit is done, they calculate and analyze their own data. They figure out, oh, well, look, our class really likes sweet snacks. And then they can break down boys and girls and so forth, so on. Okay, data society, we make sure we talk about that one too as we go. And that one kind of like, as the whole year goes, we talk about, hey, what does this look like out in the real world? So to get that going. Data cycle is what we've chosen to use. This is probably not too exciting to many of you, because you've probably seen it. The one thing that we do stress is that we try to get the teachers to understand that this is not the scientific method. Scientific method generally has a start and an end. You pose your question, you develop your experiment, you get your data, and you say whether your hypothesis was correct or not. The data cycle it doesn't really have an end. But I like to tell people it ends when you run out of grant money. So that's when the end is. Oh, grant money's gone. Oh, this cycle is done, right? Now, within the data cycle, what we also say, you do a scientific experiment. So maybe sometimes within your data cycle there, like when you're analyzing data, you may have to go like, oh, wait a second, I need to do a quick little experiment over here, and it's a true linear type experiment. But the idea is that they need to go through, look at the data to ask questions. You consider what data you have, figure out how to analyze it, and interpret visually. That's the big thing. Okay. These are the possible graphs and charts that they'll make. These are straight from Google Sheets. You can see that that's the one from Titanic. You can see that 77.48% of the female died on the Titanic. 86.69% males did. Not too good on the survival rate. Histogram, salty and sweet treat, that comes from their food habits campaign. And then just so you can see, these are the same types of things, but they'll learn how to do these in our studio. So the two tools, though they are graphically different in use, I would say in presentation, you can still get to the same thing. And that's the point we want to make with them. We want to say, so they need to know, why did they do the bar chart like this? They did this because salty and sweet were categorical variables, and they could count how many, afternoon, evening, mornings were for that categorical variable. Why did they have to do, the frequency chart over there, or the difference chart? They need to know why they needed to do these graphs. So choose the right visualization for the data that you have. It's funny to see some students do a bar chart right here with numerical data on both sides. Like, why do I have 150 bars? Why do you? Let's talk about that. And then they can figure out why. The link here the presentation has these links in here. But what I'm going to say is, how much time do I have left? Excellent. That's a good thing. So if we look at some of these links here, the one that I really want to focus on is the first one here, Ohio Data Science Foundation's course info. If you get to this link, get up there, got it. Get out of the way. Cool. Okay. You see our vision again, and we talk about Google Sheets, Python, and R are the big ones we're going to get to. The mission. But what you'll also see in here are some examples of what the teacher is going to see and what the students are going to see. So we've done our best to make sure that we provide the teachers and the students with everything they're going to need. They don't need to reinvent the wheel. They don't need to come up with their own curriculum. It's here. They can use it. So let's take a look at one of the lesson plans. So as you can see, the lesson plan is a Google Doc. Very straightforward. This one is about data structures. They're going to make stick figures and use some cutouts. And the big one is that they need to know about their variables. Numerical variables, category rows, columns, rectangular, spreadsheet format, and variability. So those who have taught before or are teaching now, pretty straightforward there. Essential concept, what do the kids need to know before this is all done? So we're providing this for the teachers. And then their lesson starts. So by doing this, and each one of the lessons are the same format. So it's not like lesson one is going to look way different than lesson two. They are very, very similar across the board, so the teachers are familiar with the flow. Now, this is the first year of the Ohio version. So we already know, and we've already gotten a couple of teachers that replied or said like, hey, this doesn't make sense, or you calculated this number wrong. I found one last night, actually. So if you do look through some of the curriculum and see something wrong, if you tell me, that would be great. Don't jump up and down and yell. So far, it's working out very good. It's one of those things where you do everything you can. You know, we had a couple of teachers down in the Hamilton area actually do these in their classroom, and for the most part, it was working great for them. But now, once you open it up to all the teachers in the state of Ohio that are going to be using it, somebody's going to find something. We did one silly one that the answer was 5, 6, 4, and in the answer key we had 6, 5, 4. We transposed digits. And then we have poor teachers going like, I'm not getting that number, I'm not getting that. Oh, because that's not the right number. So there's still going to be some revisions to our work. But this, I just want to share this one out. This is just a sample lesson, so they're able to just go right through and do a lesson. Many teachers, if you've seen that, it's the same as your formal lesson plans. Not only that, we had wonderful educators even put together presentations, slide decks for that lesson. So they didn't even have to do that. And we stressed to the teachers during training, this is a Google Slides presentation. You are more than welcome to make a copy of it and put your own templates or whatever. Use every one of the slides, add your own, it doesn't matter, make it your own. I'm a firm believer in that what works for the kids that are at Centerville High School may not necessarily be what needs to be done at Tri-County. Two different school districts, okay? What works at East would never work at West. So it's for them, they can do what they need. They don't have to reinvent that. So this is it's kind of like the AI for them. This gets them started. They don't have to redo everything. And you'll see it's just your typical, what variables do we see in the lesson? How is a variable shoe different from the variable height? Driving home the point here that our data science foundation course for the Ohio version is we want them to know the data science part. Not really care about the tool as much. Do they know what the difference is between the shoe and a height in this data? Hopefully height, they get to figure out that height is going to be numerical data because it can be any number along the continuum. The shoe size, even though it's a number, they have to realize that no, it is a finite. That really throws them for a loop. They're like, I didn't think I could use numbers. Oh, yes, you can. Answer key. So we even have an answer key for our lab. So what we did our best with on the answer keys is try to, anything that has an answer, we changed the text color. Showing up blue there. So the students will get this document though, but they'll have that question and this is how they're going to need to answer their question. Now, you may have seen at the top, it says Data Science Journal. Again, this is teacher, how do they want to do it? We have several teachers that buy those themed books, and that's what their Data Science Journal. So that is what they record all their information in. I'm like, they have a computer right in front of them. But hey, great for that journal, we go right ahead. Many others will make a copy of this in Google Classroom, send it out to them, and the student actually has to type in their answers there. And they'll be able to share that document back with their teacher. So many different ways that they can go about getting student work back to them. But for the teacher, the answers are there. We scroll down a little bit more just to see some more. What three variables are categorical? All right. And then even once they have to do some graphs and charts, they put them in here. So this is a good one. This is like, what are you doing on that one? But the idea is the students do it wrong so they can see what's wrong about it. Okay? Now, so that is a lab. Here is an actual lab that they would do. And what's cool is if you go out to these and follow these links, you can do them too. So this is an actual lab talking about frequency, right? It does say follow along with slides. If the teacher is using the slides to work them through this example, they can do it. If the teacher is not using slides in the front of the classroom, the teacher can just tell them to ignore that or take it out, right? But then they start going through here, use time use survey data. How do we summarize categorical variables? So they go in there. How do you do pivot tables? And there's our first Google function. So we teach them this. So they'll get used to, oh, typing equals sign, and start typing the word count. And what we stress to them, and what really blows the minds of teachers, because the teachers really haven't done this, you get this big drop down of everything that starts with COU, all the work. I'm like, you don't even have to memorize this stuff. Isn't this great? It's all right here. And we work through them, and we teach them how, when they see that, there's a help file, they go out to the help system through Google, so they can see a lot of information. I drive home this point because if you've ever used R, does R have that? Not many, at least not R Studio Cloud. You either know the function or you don't. And then if you go out and try to Google that function, and you don't even know what you're Googling for, and then you get all these answers back, and you're like, what's going on? That was one of the biggest, I'm going to say complaints, that teachers and students who are using UCLA version would make. They're like, I can't make it do what it's supposed to do. I can't find the answer. And even when I do search for it, I don't understand what I'm getting back. This still holds true for like ChatGPT and all our AI. You can put that question in there, but it's going to spit it all back in our language. And if you don't know what you're looking at, you don't know if it's going to be real or not. So that was one of the biggest reasons why we said, you know what? Let's go with Google Sheets. We have a lot more resources available for that. And in fact, if you wanted to know about the COUNTIF function, I guarantee you, if you go to YouTube and put in how do I use the COUNTIF function of Google Sheets, the first 50 of them are going to be from second graders that tell you how to, and show you how to use it to its fullest advantage. So, and it's understandable. So that's why we went with Google Sheets. So they'll learn how to use functions in Google Sheets like this. Oops, my phone just heard me say, hey, Google. Sorry, I can't help you with that. Inside the lab, we even try to show them exactly what they're looking at, try to explain to them, okay, what does it, why is this highlighted? And then show them that there's the range that they're looking at. So the entry level to using Google Sheets to learn how to analyze data is way. And we find this very, very good for students. An example, we love these examples, right? The teacher did UCLA stuff, but also incorporated a lot of Google Sheets with them, okay? So the students knew how to make pivot tables. Superintendent walks into the classroom and said that she needed to make a decision about something and she didn't know how to look at the numbers. And so the student goes like, well, you have the numbers in a spreadsheet? And the superintendent goes like, yeah. He goes, can you share it with me? She does. And within 2 minutes, the kid puts a pivot table together and turns around to the superintendent and goes, there you go. And she's like, what? The answer's right there. Had this been done in R, the kids would have had to import the data into R. They had to make sure the header row is okay. They had to make sure that they put in the right function, and then share it back out with the superintendent. You know, he just did it right there on her spreadsheet. She had it forever. Okay? So another good reason why we kind of drive home the use of Google Sheets. Now, another thing that we'll talk about should open up here. What kind of data do they use? This is American time use data. And yes, I probably have about 85 copies of this one. But this is the American time use data that the students look at. So they spend some time first just looking at the data, okay? So they look at the data, they got to see what's in there, they got to see that they've got some things that are missing. They look at the top of the header row. So they'll see the header row and they'll see that those are the big questions that were asked. And for the American time use data, some of these questions are kind of pertinent to a student. Just like, do you have a cell phone?
Is your cell phone a smartphone? Do you use Twitter, Instagram, Facebook, Snapchat? Do you use YouTube? So this is a good set of data that is raw data that they were able to collect and use. So the students don't just use contrived cookbook data. Best they can, we use, like I said, there's the Titanic data, there's the time use data here. There's data that they collect themselves. Now, sometimes we will use a very snippet of data that is specific because we want them to make sure they get the answer the right way so it's not confusing for them. But by and large, they have to deal with it. One of the first things that they have to figure out on this one, when they bring it into like Python in a pandas database, is they cannot have headers like this. They can, but that's ridiculous. Because if you're like, do you have a cell phone? When you want to refer to that column, you have to put in brackets, do you have a cell phone? So the first thing that they learn is how to clean the data. Change those up to something more useful when you start programming. Because if you are always printing that out all the time, that takes forever. But Google Colab is getting a lot smarter now. So when you bring in your data and you have it like this, sometimes it even starts popping up, oh, this is what you want to do next. It's kind of like a grayed out. All you got to do is click tab, and there it is. So it's already thinking ahead. And what I've noticed on some, it didn't do it on this one for me, but if you do start typing do you have a cell phone, it pops open all the column headers there. So cuts it down a little bit, but it's not good data practice to have huge column headers and these big questions. So they'll learn about that. Okay, that's that one. When appropriate or when needed, our good friend, let's see, hopefully it'll work. Fingers crossed. We might be getting blocked. Nope, there we go. There we go. Wonderful. Next. Get out. Go ahead. Close me. Is it at the top? Does anybody see an X anywhere? We're in the conversation. Wonderful. Close. Jeez, all that to get to here, huh? Play button. We won't watch the whole thing. Well, he is talking, but we might be muted because everything else going on. Yep. Unmute.
And I'm going to hit Control C and copy this data. I'm going to add a new sheet down here at the bottom, and I'm just going to hit Control
So
V.
many of you know Michael Ross.
You can do, file copy,
Michael Ross.
whatever, but from keyboard shortcuts. Now, this is the data we want to compare. How many, do males or females use social media sites more frequently? The easiest way to tally this data is to create a pivot table. So I'm going to highlight those two cells. They were already highlighted. Click it, so I'm going to do that. And I'm going to go to Insert Pivot Table. I'll create a new sheet on this. You can see down the bottom, I actually already have one. So for mine, I added sex, it's the same data. So that is.
So the idea there is there are several videos and screencasts, and if any teacher wants to or needs to see something done again, we can do that. We did our summer training, and we did record that. So a lot of the steps and things we did, they're already recorded. So this is another thing that is good for the teachers, something that the UCLA course didn't have. It's like if you didn't go to the training, you didn't watch what happened, there was no video library you could go to. These are done specific, like the pivot table. That's a big thing. This is specific. Teacher can go right here and see how to do the pivot table. So we offered those up to them too. And we'll look at this one just for completeness. So for this one, they've got to start looking at how are they going to be able to get something to recursive. So they need to do something, they've got something that they need to do 500 times. So what we did have to do is find a way to get Google Sheets to do that. In our studio, it's pretty easy. You just say do 500 and tell it what to do, and it'll do it 500 times. But that's also proprietary. It is in that do function is part of UCLA module. So if a kid goes out and interviews with a company and they go, do you know how to use R? And like, yeah. Well, we need to do this 500 times. If they try to do 500, it's going to go like, I don't know what you're talking about. So even when we do switch over to our studio, we use like the basics. We do not rely on anything, no other library. Only time that we do bring a library in is when it's like, this is industry standard. For instance, in Python, Pandas is an industry standard to deal with data and data frames. So we teach them how to use the Pandas data frame. Our view on that is any place that uses Python to analyze data is going to use Pandas and NumPy. So using those libraries is like, okay, we can do that. But with our studio, there are a ton. There's the Mosaic library that's used for that's math and science oriented. There's a Matpot library that both for our studio and in Python. There's just a whole bunch of them out there. So yeah, it makes your life easy. But if you don't train on it, how do you know how to use it? So we would much rather teach the kids like you got nothing. You need to use bare bones R Studio. Yes, there's a library that makes your life easier, but no, you need to know it bare bones. Problem with Google Sheets though is we didn't have, there was a very difficult, cumbersome way to get it to do that. So we did have to break down and we created our own little library for Data Science Foundation. But it's open source, it's free to use, you can look at it, you can ask me any questions about it, I'm the one who wrote it. So. But all it did was, what we did was we took something that could have been done in Sheets, but it just would have been very cumbersome. We just took it to make it a little bit more straightforward. And we use it as that bridging step to like, okay, there are libraries and other things that you can use. And we do talk to some teachers that let them look at the code so they can see what it's actually doing. And you know, it might inspire them to do some more coding on their own to automate Google Sheets. So by the time they start using that, they have kind of grown a little bit, so they know what Google Sheets can do. Now they're going to use this library to make Google Sheets a little bit more powerful. And then they're going to go into our studio and see what our studio, bigger, powerful data analyst engine can do and talk about some of the libraries that you can use with it as well. But like I said, so to do this one, they will have to use a library that's been written for us in there. So far, haven't had any problems. So if we open the spreadsheet, they'll make a copy. And yes, I probably have 85 copies of this one too. But this is our standard Data Science Foundation's copy. It's listed as IDS because that's what UCLA, their course was Introduction to Data Science. So we said, nope, we need to change our name. So it is Data Science Foundation, but it did get a name change. Well, after this was done, we're like, we're going to leave it alone. But if you'll see here, there's a data science menu, and they can do random numbers and shuffling values. For those that really like to see stuff, you may or may not be familiar with Google Sheets, but Google Sheets does have code behind it. You can, much like Visual Basic for applications for Office, you can use Google Apps Script for all Google products. And man, it is wonderful stuff. And just to talk about, this is all the code that's in the spreadsheet.
If you look to see where it says IDS helpers, that's where the library of functions comes from. So there's a library called IDS helpers, and everything's in that library, which is nice because if I have to change anything, it's one place. And everybody using that spreadsheet will be fixed up. But we talk about scripting using Google Apps Script. Okay. Let me make sure that I did all that, get off of that. We looked at this one. Don't need to see this one. Did rigor. Don't need that one. Yeah, and on this sheet right here, if you go to the IDS helpers, you'll actually see the whole set of code. All right. So good there. Full screen. So questions, comments, concerns so far? I'm going to shift into like graduation requirements here. Go through those fairly quickly. This is either good or bad. Oh, Sheriff of Fairmont West.
Well, I like the direction that this course is going.
Mm-hmm.
Not only that it's not beholden to the University of California, Los Angeles any longer,
Right.
but that it's focusing on data analysis and that it's giving students access to tools that they're likely to use later on and that they can build on. And I think it's very natural. Spreadsheets are very natural entrees. So yeah, they're all happy to say things as simple as equals sum of this column, average of this column of data, or this area of data. Right. So they're really using codes they're using commands, to do just about anything other than using it as just something to put up. I mean, if you just fill in numbers in columns and rows, you're not really using a spreadsheet. You're just using a tool to make
organize.
Yeah, and then paste into Word or something like that.
Yes.
Unless you're doing something with the data in the spreadsheet. You just don't. You mentioned students have seen spreadsheets, so it's not scary to students. But students have not. Most high school graduates in the United States don't know how to use spreadsheets. They do know how to use PowerPoint. They do know how to use Word, but they don't know how to use Excel. So this is a college readiness and workplace readiness. If they learn nothing else, but the ins and outs of how to use spreadsheets, and that would be a very valuable thing. So I think that this is, and then they go on to use our Studio and Python, and then you said something about Looker Studio.
Looker Studio.
Looker. Okay.
So why they chose that name, I don't know, because it was wonderful. I can't remember now. I can't even remember what it was called before Looker Studio, but it was something data something, and it was like a perfect name for exactly what it is. And they changed it to Looker Studio, and that everybody's like, you are saying L, right? No H in front of them, like not an H. So, but it's still the same thing. And what are you asking? Like, what does it look like?
No. I just want to make sure I never saw it written anywhere, so I want to make sure that I got it correct in my notes. I'm taking notes with paper and pencil, not using my.
Hey, that's okay.
Sorry.
No, you're fine. Yeah, that's right. Yeah. See, those from East kind of graduated. But Looker Studio is used in their final project. So they get to see how to do Looker Studio, which is a big data dashboard, and then their final fourth quarter project. They get to choose whatever they want to do. What we're hoping is that they'll just use Looker Studio to build another dashboard. Yes.
I have a million comments about Tony Brady. I'm not doing that, so I'm talking. First of all, he is absolutely right. Kids do not learn spreadsheets. I feel like that should be the math department's responsibility, but I am probably the only human in my building that puts spreadsheets in front of kids ever. I'm teaching the QR course, and they have to do a budget for the project. So I just did some spreadsheet stuff in advance, and they still want to put in the numbers and then figure it out in calculator.
Like you have a calculator on steroids right here.
And so, like, when I grade them, I'm like, I'm going to click on the cell and look up here to see that it's a formula. Like, I want to see your formula. So that's cute. I love this.
Great.
So, right, everything. But then the other issue is this, getting into the cohort. I've done a lot of, I was on the groups that wrote the standards for some of the HEs, like I was on a couple of those committees, and I did some different stuff. And so I was like, yeah, we're going to do data science too. And so we applied for it, and we got turned down. But the timing of it is such that we had to just assume we were going to get in and already put it out there and start telling kids about it so the kids could be picking it. By the time we got turned down, the course booklets were already printed. And then we had to go back and tell kids, sorry, we don't get to do data science. Are they going to change that timeline ever? Because I'll never talk my district into applying for that ever again. If we have to wait until after the kids have already picked the course to tell them they can't take it. Any chance?
I'm going to say I'm the lead facilitator from Montgomery County Institute, so I have no control of that. I hear what you're saying. One thing that we could say about this, you necessarily did not have to not teach a data science class.
Right, we could have done it ourselves.
Correct. Which is right. And there's, yeah, we're on there. Just want to make sure that's out there. Number two, I'm going to say now, Brian will close his ears for a moment. Reach out to me. Now, we've got teachers that were going to teach the class this year that enrollment didn't happen, but they're in the training. So they're training this year. They're going to be trained. They're just not actively teaching it. And since it is now controlled by Ohio, we can put teachers in the day after. That, it's not going to kill us. Now, there is an issue of a $2,000 training cost to it, but fee, yeah, that'd be a good way to put it. But that is per school. So if you had 4 teachers, it's only $2,000. That one teacher is $2,000. I can definitely take that back under advisement and make sure that we could keep working on it. I do know that the pilot nature of these courses is pretty much done. Yeah, I get Brian to see if he goes back. So we really don't want to call them pilots anymore. So it's going to be more of like, okay, are you going to be doing data science next year? Yes. Okay. Who's your teachers are going to be there? Like, okay, these are your teachers. You will need to pay $2,000 to offset the cost of training for those teachers for that one. So should not have that issue. So sorry that happened.
We'll keep trying.
Yeah.
I still think this is the future of math education.
Oh,
That's where it's got to
yeah.
go. And with AI in existence, traditional math classes can't live. We're living in a photomath world. I mean, we need to figure out what math's supposed to look like, and this is it.
Exactly.
But I can say exactly.
Hang on. Behind you first.
Why here?
Hang on. Behind you first. Anything. He's been patient.
I've talked with a lot of pretty small school districts, and because of limited capacity and stuff, they're not going to be able to embrace all these pathways. Now, throw your bias on the table, which is the bestest of all these Algebra 2 equivalent alternatives that we have.
I teach QR and I teach statistics and better.
But
Okay, so
I am going to say,
now they're going to say why.
but now here, listen to Brian. See, he just said the street.
Well, no, you said it wrong. I'm sorry, in a different way.
Higher ed, you tell you, just it's a probability with the broadest applicant math course you could take, because students are more applicable and more degree programs in their field.
However, there you go.
Ohio,
He's going to be over here.
How to teach that, and what's typically taught from a typical textbook is junk. And data science would be a much better way to get students ready for staff
Correct.
at higher ed
Can you take
than a traditional,
I like it.
Oh, well, I'm going in a different direction, and I don't want to cut off the fight. My question has to do with other areas besides math. Because, as you said something about English and regard to it, I really wonder about how you're integrating this, especially with science, but also with like regard to social studies and learning how can this really permeate those other areas.
We kind of have an idea, all right, which we'll talk about with simultaneous credit. But I am with you on that one, and I do not know how to do it, but it is one of those, it needs to be done, so we should do it. Springfield Clark CCC, I don't know if they still do it, but when I was teaching at the Green County Career Center 12 years ago, Springfield Clark CCC did away with all their English classes, and all the English teachers were put in the lab. So in your welding lab, there was your welding teacher and an English teacher, and they taught English in the welding lab. So they were able to, the English teacher would be like, okay, this is what you're doing for welding. How can we apply this to what you need to do for English? I'm sure it was really strange at first, but it worked. Now, I'm a young pup. It's my understanding that that's the way it used to be. They used to call it related. And the related teachers were in the labs with the students. It wasn't until this big push for certain credits of math, science, social studies, and English that they finally say, oh, we're going to pull them out, put them in their own class. So now a traditional career center, you take 4 or 5 periods of your traditional reading, writing, math, science, and then you spend the other half day in your lab. So I think putting them more together would make sense. I'm sitting there in business class teaching, things about electrician and electronics, while the electrical wiring teacher is doing the same thing, and we don't talk. And it's like, let's talk, because at least some of the words that you use in your classroom, I can use in my classroom, and vice versa. You can say, hey, we're getting ready to do this. When you're down in Mr. O's class, you're going to do the same thing, okay? And in my other little soapbox, I am a physics teacher, but I taught math. But I could not give any of my students credit in math because I don't have a math license. Now, when CCP rolled out, I could be able to teach college level algebra because of all my college work, okay? So I could be in this classroom teaching these students, teaching physics, and then another set of kids come in and teach them college algebra. But I could not give them a high school credit. To me, that boggles my mind. We need to get away from that. It needs to be more, I'm a very pro standards-based assessment, competency-based assessment. Here's your standards. It doesn't matter when you learn them, you just have to learn them. And who teaches them to you? Whoever. Okay? You get them. And plus, if we do have the standards, how much more? 14 minutes. 14 minutes, okay. I caught that. So, getting that moving forward would be great. That we blur the lines. You shouldn't have to worry about, am I in English class, am I in math class? This should be, you go to school, and this is your project that you need to do, and this is how it's going to be, assessed, if you will. So that would be great.
Well, first say, I love what you're saying, because real life does not work in those silos, right? And we have way gone down that road too far. So we need to get back to your point about using these things in the other subjects. That's what these things are used for, right? That's where it is. So when I originally raised my hand, it was just to say, even as much as I know about how science is being taught in the state, I was still extremely shocked to hear people say, almost no students have ever used a spreadsheet when they come to college. Like in junior, I taught 7th and 8th grade science, and they all know how to use spreadsheets and put formulas in there. how on earth are people analyzing their data in their science courses, right? I mean, and I'm talking 15 and more years ago. And still today, a science teacher is not using a spreadsheet for their data. But I love that they're going to do some of this in math class now, because I also, like you, felt like I had to teach them all the science, or all the math that supported science data analysis in my science class. Okay, what were you gonna say?
Right, you have people in the department, I'm not gonna name all, they can't do in Excel what you just described.
Okay. Well, 12-year-olds can easily do that, right? I mean, these are simple formulas that have words in them, right?
Word and math.
Yes, yes, that is crazy, that's crazy. So which one of these courses is the best? Obviously, I'm gonna say data science because I'm the lead facilitator for it. Discrete math is another one because I really, really like that one. Quantitative reasoning is good. I just think that's in order of, I'm gonna say in what I like, that's going. And then the stats class would be the last one. I would, and if I were teaching a stats class, the stats class would probably be taught the way I was teaching. Science. So.
I think that's the problem there, the stats class, because we didn't really touch it in the way we did the others. It's still a traditional class, probably in most high schools.
Yeah, yep.
Just a quick comment too, back on what Rod was saying, that, I mean, I think, I know it's not the easiest, but I think districts have to start considering how can we, again, I know this isn't the easiest, but how can we, create essentially Zoom classes and like have 5 or 6 districts teach a data science class, something like that.
Yep, not impossible.
So there's something called engagement. Education.
Yeah.
And it's been devised at CTM about 5 years ago now. And it's built into the math standard, K through 12, in the state of Ohio. But most teachers in Ohio have no clue what it is, what that is, what it's about, and it certainly aligns with the data science. So I think there's a need for statistics education in the spirit of the Gates report for all math teachers in the state of Ohio. And I think the traditional statistics course that's taught in high school and in college is not what the American Statistical Association says should be taught. So this is much closer to what needs to happen. And AMATI, its special interest group for statistics is now statistics and data science. So at least at that area of higher ed, which is like half the students in the United States are at institutions that are two-year colleges. And so data science and statistics are siblings. They're very, almost going at the hip. And so, anyway, I don't think that people, if you took a statistics course as a student and have never done anything since, that's not what statistics should be now. But that's what it is most places.
Yes.
As long as the students learn to rationalize denominators.
No, what I really want to say is it would be useful, I think, for people to be paying attention to what are the underlying understandings that are necessary for students to make sense of these visualizations and the data displays and things like that. I mean, certainly relationship between quantities is a big one, but one that often gets missed is area. I years ago sent a really nice area model of the marginal income tax rate to Vox. And Vox.com is known for its explainers and charts and graphs and things like that. And the response I got from the Vox folks was people won't understand it. Because it required area in order to, right? The trouble with the the marginal income tax rate, if you do it according to the rates are close to lines that are almost the same as each other. You can't see what's going on.
That's changing, right?
So in this area model, it makes a whole lot of sense. But these people who try to communicate to the public about these things, says no, sorry, it can't be done, or won't help, right? So let's figure out how to make it help. Let's put
The right thing to do, the way to make it happen.
Work on it.
You are correct.
So what is nice is the number of districts and teachers that are using data science or implementing data science is growing. We do have that line though from Cincinnati, Columbus to Cleveland. So we got to get to our
Put a circle around Athens. And what is rated at before you live?
Yeah.
Looks like Noble County, maybe is the closest
Yeah.
one.
Well,
Like,
Lancaster and then, yeah.
Yeah.
you know, some of it, there's no students out here. Teachers out
Well,
here.
that's what- No, too far, right? Right, that whole southeastern Ohio.
Yeah.
Vacant.
Well, Northwest, we get the same thing up there. too.
Isn't there two big colleges up there? Ryan and Bowling Green? Anyway, so we're trying, and the goal is to get every school in the state of Ohio to have at least one of these classes in their high school. So that is the goal.
How close to that goal are we?
Not very, but getting better. So, but Brian may have me off the top of his head.
I'm literally trying to fall off the top of my head, what data point do you want?
I mean, what percentage of the high schools in Ohio have one of these pathway courses? One or more. You don't know.
We've worked with some of the 300, we've never cross-referenced that deductively.
Right.
Yeah, okay.
So about 1,000
And
and 200 to 300.
smaller districts, what we're seeing happen too in the data, vice versa, but smaller districts, smaller teacher staff, odd number of years they offer this pathway course, even number of years they're offering that pathway course. I don't know what that does to the answer you're looking for with, you know, what are they offering? Well,
But the kids,
is it odd number of years?
the kids still have the option. They only take a couple of years that they're eligible for that.
So it's like they not.
Yeah, so I would say, again, somewhere probably in the 200 range, but we have over 600 districts.
Just a public school.
Yeah.
Correct. I think we made a sizable dent. If you can factor in, okay, well, here's another number we can't lock down, statistics and probability. Because we want statistics, probability, statistics and probability, CCT, AP, like, there's so many different variations of that to try to lock down who's offering what, where.
Yeah.
And are they?
So there's work to do. We do know that.
Other great questions. So back to my discussions with school that's considering
Which one did you?
algebra 2 equivalent thing here. And, you know, looking at the big picture, this is likely a course that they could potentially take as a senior or as a junior, something like that. And if I go to the MMR, then I know I'm going to be a CCT student in 2R in my senior year or something like that. If I go the data science track, what's my senior year 4th credit CCT course of choice?
Same thing. Brian may be able to list out names of courses that they can take, but these courses do not stop them from doing the next.
But if I'm paired up with a higher ed school that I'm doing CCP through, is there a
I see where you're going with that one, and that question did come up, and it's one thing that I am going to actively look at, because we do have a district that has run into this problem. They have an forget what college it is. It's North. I think the teachers or the admins from Pickla. What's happening is the kids are trying to go to a college, and since it doesn't say Algebra 2 on their report card, they're having a problem placing them in math at college. So I'm thinking that's a higher ed issue, but unintended consequences of our situation.
Just back to the question of if a school has only capacity for one of these courses, what should they be doing? That's where your local lens is so important, right? What kind of jobs are available in your area, or where these kids are going to go? What college are a lot of these kids going to go to? And that, I think, what you base your decision on
this would take us to a totally different presentation, more geared toward parents and counselors, but Ohio Means Jobs has a tool that students can take. It's about a 10 or 15-minute survey. It will give them suggested careers, but if they were to pursue those careers, it lays it out in a beautiful color-coded table that can be the beginning of their required graduation plan.
Mm-hmm.
And so it really could become, you know, a tool that districts use to determine, okay, based on our needs, based on our students' interests, what do we offer in addition to Algebra 2? Look at your data, and then maybe your smaller district, you look into that odd number, even number year option. At least it feeds into, we're offering courses that students want to get them to where they want to go versus where we think they want to go, or where we wanted to go 25 years ago.
So what's the data on the users on that particular system?
Since it's an Ohio Means Jobs webpage, here's like, we can track, if I send you to OCTM, I can track OCTM. I can't track any second, third page update. I can't track when you get to Ohio Means Jobs. I have to see their website, what they're using, how far they're that's the thing. We know we need to do a lot better. A lot better. We don't even do a good enough job of analyzing counselors in the district halfway course.
Yeah. Well, and college admissions.
That's another one.
One more, then we'll go,
You're right.
It occurs to me that we need to thank the schools that were offering integrated programs 20 years ago for the fact that this exists.
we're back.
Because it was Bob Pass, last gas in 2006, as he was leaving to pass the Ohio Court legislation that required Algebra 2 or its equivalent for all students.
Right.
And the reason for that was because when the chief report that said Algebra 2 causes college readiness, but the only thing they could point to that was more than Algebra 1 is geometry at that point was Algebra 2, right? So those of us at the Ohio Department of Education, this is one of my first big tasks when I got here in 2007, was to try and figure out what it meant. And many people in this room were working on, so wait a minute, Algebra 2 for all students, let's see if we can make it useful. We started calling it A2E, and we, so that we might think of something different. And it took, 15 years to significant change to start moving. But if it hadn't been for the courses offering integrated programs, it probably would have just said Algebra 2. So let's thank the half a dozen school districts.
This is almost lunchtime. Let's let Michael wrap up his presentation.
Yeah, we'll go through these pretty quick. These are just the graduation requirements. Many of you know that the graduation requirements have changed 2023 and beyond. 3 big areas: they got to get their credits, they got to get their competency demonstration, and they got to do the readiness. What is really cool is readiness demonstrations. They can use the seals. There are many seals that they can do. The one that we focus on is the technology seal. A student can actually obtain a technology seal by taking either the data science foundation course or the discrete math course. So this is another bonus for taking this class. They get a graduation seal along with it.
Just one course gets you a seal?
Yes.
Oh.
Just passing the biology exam.
Yes,
That's another issue. Yeah.
So if you want to look at a little bit closer about, exactly why, we've got a lot of words to it. What I'm just saying is that everything that we do in the data science class and the discrete math class meets the requirements for a technology field. So that's good there. Back to combining, integrating, okay? Simultaneous credit. We're trying to push this one. Brian got me thinking about it last year. Traditionally, you got a math teacher doing data science. You got a computer science teacher doing computer science. So they're in 2 different classes, but they're covering the same stuff, kind of, right? So why can't we do these together? You've got the 2 teachers, teacher 1, teacher 2, 2 classes. Well, what if you had the 1 teacher in the classroom and you did a credit flex program for the computer science part and let that computer science teacher evaluate it? So 1 teacher in the classroom
They're the math teacher, they're doing the math, they combine with a licensed computer science teacher. That computer science teacher just verifies, make sure the teacher is doing what they're supposed to be doing. And then the student work gets evaluated by that second teacher. One class, one period, 2 credits. Pretty cool, pretty cool. You can even do this where the teacher is not in the building. I'm trying very hard myself because if I just take the computer science test, teacher test, I can have that added to my license. So that could be something that the ESC offers to these schools. They're like, hey, listen, you can partner with us. You teach the data science course or discrete math. I'll be the computer science teacher along with you. You know, and then we'll just meet periodically. And then at the end of the year, we'll evaluate the student and they'll get 2 credits. So that would be another way to get in. You know, I have a bunch of questions. Recap right there. So did you like my question? To wrap everything up, excellent conversation. Invest in Ohio's future. If we look at the job landscape that's coming up, it's changing. It's changing every day. It's changing rapidly. I mean, back, you know, data scientists, data analysts, you know, 6-7 years ago wasn't unheard of. Web designer. I can remember graduating from high school, and that was, well, not high school, and computers were coming out of high school. Then I can remember when the World Wide Web was coming out and HTML coding and all that. Well, my brother was a database administrator, and he was able to make tons of money real fast because nobody else knew how to do that. You know, and website designers, you know, they could make a lot of money. Now, I'm telling you, in 3 minutes, we can have a Google site up and running that will take credit cards as a payment to run a business. And 0 HTML code. So things have changed, right? And what we're saying, if we support these classes, okay, like the Data Science Foundation, we can provide these opportunities for our students so that they will, one, be able to compete in the workforce and be able to contribute to the state's economic growth. We do like the idea that they're born here, learn here, stay here. That's what we like in Ohio. And I can tell you, it's been around for a lot of states. And what we have going here in Ohio is pretty awesome, right? Right, Pat Air Force Base there. Joby's coming in close by. It's just the Intel chip. Ohio is going to need a lot of technology workers. And that wasn't unheard of a couple of years ago. So, just wrapping it all up, this was presented to you by Department of Education Workforce, OMSC, and myself from Montgomery County Education Service Center. Feel free to reach out to me if you have any questions. If you need any links to anything that we've got here, I'll be more than happy to share them out. Thank you for your time, and now I don't want to be between you and lunch.
Thank you very much, Michael, for that very informative talk.